Hello, my name is Keshwani. That's K-E-S-H-W-A-N-I, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 857. Please turn to it. 857. And today is our lesson number 116. This section that you see there on page 857 has 16 questions, as you can see there, and they are all of the same type. They are all multiple choice questions, unlike the unlike one of the other two sections where they give you, in the beginning they give you multiple choice questions and then they give you the gradient questions. Since these are all of the same type, the scale of difficulty starts with number 1 and ends at 16. It continues, which means the first 5 or 6 questions are going to be easy, the next 5 or 6 are medium, and the last 5 or 6 are hard. In this particular section, 1 through 5 are designated as easy. We'll see. Number 1. For which of the following values of m will the value of 3m minus 1 will be greater than 10? And they give you all sorts of different values here. It's a very simple thing. Obviously it cannot be 3 because 3 times 3 is 9, 9 minus 1 is 8. It's got to be 4. 12 minus 1 is 11, which is more than 10. The answer is A. Sometimes I feel even silly to do these questions because they are too simple. Answer is A. Number 2. If A times K equals A, well, if you have a number times another number equals the number that you started out with, for example, if P times Q equals P, then the only way that is possible is if Q, this implies that Q must equal 1. That's the only way that is possible. The only way the product of two different numbers, is same as one of those two numbers is if the other number is 1. Notice how I said it. I'm going to say it one more time. The only way the product of two different numbers, why did I have to say different? Because it is possible for two same numbers to be such that their product happens to equal to one of the other two numbers, which is this scenario. 1 times 1 equals 1. If A happens to be 1 and B happens to be 1, then A times B equals either A or B. Which is why the emphasis, as long as we have a product of two different numbers, which happens to equals to one of those two numbers, then the only way that is possible is that if the other number happens to be 1. So here, this implies that K equals 1. Again, I think I did it again. I made too much fuss about it. The answer is D. I do not know why I do that every single time. It is too freaking easy. It's number 2 for crying out loud. Number 3. In the picture above, L and M are parallel. Alright. So we have line L, which we are told is parallel to M. And we have a line here. This we are told is X. And this we are told is 80. Well, if this is 80, and since these two lines are parallel, if you have two parallel lines and a line intersects, then this angle must equal that angle, which is your X and the 80, which means X equals 80. So far so good. Similarly, if we have two parallel lines and a third line intersects the two parallel lines, then this angle must equal that angle. And that they are showing that, this angle they are showing that as Y. And this is 70. Which means this angle here must be 70 because this is Y. The question simply is, how much is Z? How much is this angle Z? Well, that's very straightforward. That's very straightforward because we know that a straight line makes 180 degrees. A straight line makes 180 degrees, which means 80 plus Z 80 plus Z plus 70 equals 180. 80 plus 70 is 150. and therefore Z equals 30. The answer is A. The answer is A. Number 4. Problem number 4. The scenic route from Mia's home to her office is 5 kilometers longer than the direct route. So here is our direct route, and here is our scenic route. And we are told the scenic route is 5 more than the direct route. We are told the scenic route is 5 more than the direct route. When she goes by the scenic route and returns by the direct route, we are told that the total trip is 35 kilometers. Alright, so we know now that the scenic plus the direct route is 35 kilometers. Question simply is, how long is the direct route? So we just have to solve for D. We just have to solve for D, but we know S equals D plus 5, so put it in here. S equals the direct route plus 5 more, plus D equals 35. So here we have D and a D, so 2D equals 30, if you subtract 5 from both sides, and D equals 15. The answer is C. Number 5. Problem number 5. A complete cycle of traffic light takes 80 seconds, alright? During each cycle, the light is green for 40 seconds. So it remains green for 40 seconds. It remains amber for 10 seconds. Oh, how chic, huh? I do not live in a town where the lights turn amber. They turn yellow. And red for 30 seconds. What the hell are they asking? At a randomly chosen time, what are the odds that the light will not be red? Will not be red. Will not be red. If it's not red, it's got to be either green or amber. So the odds of not red is same as the odds of green or amber. And the odds that it's going to be green or amber is 40 plus 10, which is 50 out of 80. Because the entire cycle is 80 seconds, of which it remains green for 40 seconds, it goes to amber for 10 seconds, hence 50 seconds total out of 80. You divide the top and bottom by 10 and you end up with 5/8. The answer is B. Amber, eh? Well, perhaps one day I will move to such town, a very sophisticated one. Number 6. For a certain hot water heater, the increase in the heating expense is directly proportional to the increase in the water temperature setting. Alright, obviously it makes sense. The higher you set the temperature, the more you're going to pay for it. If the heating expense increases by $24 when the water temperature is increased by 20 degrees, well now we're getting into nitty-gritty, it's a proportion problem. We have degrees and we have dollars. I meant to say degrees, D-E-G. We have degrees and we have temperature. And we are told that if the heating expense increases by $24, it increases by $24 when the setting is increased by 20 degrees. So technically this is not degrees, this is the change in degrees. How much you change the degrees, how much you raise your temperature. So if your house is set at 60 degrees and you raise the temperature of the house to 65 degrees, you've changed it by 5 degrees. And every time for a given change in the degree temperature, the amount of money that you can spend on the fuel is going to change, obviously. By how much will the heating expense increase when the water temperature setting is increased by 15 degrees? Alright. 15 degrees we're going to change, and the question is how much is that? Look, this is very simple, very straightforward. You can do what we are about to do, which is a very traditional method, very orthodox method, very classical, very conventional, very academic method, or you can simply see that 20 is, or rather, we can see that 15 is 3/4 of 20. I hope you are able to see that. This 15 is 3/4 of 15. Therefore, the amount of money that we will spend will be 3/4 of before. Before we were spending $24 for a change of 20 degrees. Divide top and bottom by 4. 4 goes into 24 6 times, so 6 times 3 is 18. So this is one way of doing it, $18. Another way is to what we were about to do, which to cross multiply and solve for x. Let's go ahead and do it. Cross multiply, so we get 20 times x equals 24 times 15. Divide both sides by 20. 20 drops out, and x equals this quantity. Divide top and bottom by 4, so this gets 6 and we get a 5 here. Divide top and bottom by 5 and the 15 becomes 3. Voila. 6 times 3 or $18. The answer is B. That was the end of it. That was the end of the good old days. Now we begin to get into problems which are going to get a little bit more nasty. Not very difficult, because we are now going to move on to the medium problem on the next questions. And then of course the hard ones. I will see you tomorrow, okay? Where we'll begin with page number 859. Alright? Bye now.